Hello everyone. In this session, we will be discussing the Unit 2, which talks about computer arithmetic. And in that, we will discuss binary multiplier. So, binary multiplier, we have different types of multipliers. First multiplier is the array multiplier. In the array multiplier, we will see how we can implement it in the circuit using the basic gates and the full adder circuit. So you have the multiplicand and the multiplier. We have taken a 4 cross 4 binary number, and this is the partial product, and we have the final product. So if we see, if we want to multiply the one bit of multiplier and multiplicand, it is just your AND operation. So you have an AND gate which takes the input of the one bit of multiplicand and one bit of multiplier. Now the outputs of the multiplier uh, AND gate will give you the partial product. So for the first partial product, row of partial product, you will need 4 such AND gates. And the outputs of the AND gates will be given to the full adder. So initially we can imagine the partial product is all zeros, and you are adding the first partial product with zeros. So you need to have a full adder. So output of the AND gate and an input from the partial product, you will add and you will get the output from the full adder, which will be the sum and the carry out. So if for the 4 by 4 multiplication, you can see you need an array multiplier which is represented for 1 bit here as 4 into 4 16 bits. So for each row, you can see the carry in for each row will be 0, which goes into the full adder. Then you can see Q0, Q1, Q2, Q3, that is the multiplier bit which goes to each row of your partial product. And then in the top you can see M0, which is common for all the diagonal, M1 for all, M2 and M3. Then you can see the array, the output of the array, which is the sum which goes here, and you have the carry out which goes, and from the last you will go to the next level. So this is the uh, implementation of an array multiplier, and this works only for unsigned numbers. And you can see the final partial product, which is the output of each array cell. And this circuit can be used only for a 4 cross 4 multiplication. If we have some other combination of multiplier and multiplicand, then it is not flexible. So you have to go in for other sequential multipliers. This sequential multiplier will work for a positive multiplier and a negative multiplicand. Here you can see registers. C, a register with, A, which is initialized with 0, and the register Q, which is initialized with the multiplier, and a register M, which is initialized with the multiplicand M. So here when the multiplier is placed in the Q register, and you need to decide on the least significant bit Q0. So it is given as an input to the control sequencer, which will decide whether to add the multiplicand or not. So if it is equal to 1, then here the multiplexer input will be equal to 1, and multiplicand will be given to the one input of your adder. The other input comes from the register A, and this is again stored in the register A. Suppose the Q0 bit is equal to 0, then you will have no add, which is an input of 0 to the multiplexer, which in turn will be added, 0 will be added to the register and is saved here. This is the sequential, and the iteration has to be repeated for the number of bits of the multiplier. So we can see an example of how a sequential circuit multiplier works. So here you can see the register C, register A is initialized with 0, register M with the multiplicand, and the Q register is initialized with the multiplier Q. Now you can see you have to decide on based on the Q naught bit. So Q naught bit is 1. So you need to add M to the register CA and you get this. And in the next iteration, for the next iteration, you should shift the Q naught because this Q naught is multiplied. So you have to shift right, and this is the content of your registers now. Now based on this content again you have to decide. So here it is 1. So you are going to add M again and then you have to shift right. Then here it is 0. So it is adding zeros. So you can add 0 and you can come here. Now it is again 0. So it is shift right and now it is 1. So you have to again add M to this and you will get this. Then finally shift right 1 bit. So 4 iterations. So after the 4th iteration you will have the partial product in the register A and Q. And this works for a positive value. So here you can see how in the manual way we have to do the multiplication, and the difficulties with the signed number is in when you use a sequential circuit multiplier, the when you shift right, the most significant bit will always be equal to 0. But if you have a negative multiplier or multiplicand, then you can see the when the negative numbers are there, the sign extension should be ones if it is a negative number. So that is the difficulty in the sequential multiplier. So to overcome that, we'll see another Booth's multiplication in the next video. Thank you.